Welcome to all for this session. In the last two sessions, we are discussing about polar curves. In that polar curves, we are going to learn find the angle of intersection between radius vector and the tangent, and also angle of intersection between two curves and related problems. Today, in continuation of the same thing, but we are going to find out the angle of intersection between two curves. In the previous class, we are going to see how they intersect orthogonally. That is the topic we will be covered. Today, we are covering angle of intersection between two curves. That means we are going to find out the value of theta. Okay, so I am going to see some more problems now. Find the angle of intersection between the following curves. Find the angle of intersection for pair of polar curves. So that means today we are going to discuss find the angle of intersection for pair of polar curves. So the first problem is an r equal to 2 times of sin theta and r equal to sin theta plus cos theta. In the previous class, we know that how to elimination of the angle phi. The same procedure we have to adapt here, but we are going to find out the angle of phi here. Okay. So take down the solution. Then r equal to 2 times of sin theta. So as usual, you should have to take log on both sides. Taking log on both sides. So we have, it is log r, log 2 plus logarithm of sin theta. The product of two functions is there. If you are taking a log on both sides, this becomes log of 2 times of sin theta, then become log 2 plus log sin theta. Now as usual, differentiate with respect to theta. So 1 by r dr by d theta should be equal to, it is a constant function. If you differentiate with respect to theta, it becomes 0 plus, now differentiation of this one, a logarithm function, it is 1 by sin theta. The differentiation of this function is cos theta. Then differentiation of theta with respect to theta, it get 1. So we know the notation for this one, 1 by r dr by d theta, it is cot phi. Two curves is there, we call this first one. Then 1 into cos theta into 1, we get cos theta, then divided by sin theta. We know that cos theta by sin theta is, it's a cot theta. So we can easily eliminate these two cot. We get the value of phi 1 is theta. So now we can extract the value of phi as theta in the first equation. The same procedure we have to adopt for this equation. R equal to sin theta plus cos theta. Then again taking log on both sides. If you are taking log on both sides, then become log r should be equal to, but here sum of two terms is there. You have to remember here, if you take a log, complete logarithm function you have to take in here, logarithm of sin theta plus cos theta. So you have to write down like that. Then you differentiate with respect to theta. 1 by r, it is dr by d theta should be equal to. So as usual, you have to differentiate the function log. They become 1 divided by sin theta plus cos theta. Then differentiation of this function, they become cos theta, then minus of sin theta. So call this as an cot phi 2. there is an angle of intersection between two curve that is cot phi 2. Then you take a common factor of sine theta here. If you take a common factor of sine theta, this become cos by sine cot theta minus 1 divided by, again you take a common factor of this one, that is 1 plus cot theta. Now cancellation of this one, you get cot phi 2. Cot phi 2 should be equal to, the notation for this one is cot of 45 degree plus theta. And again cancellation of these two, we get the value of phi 2 is 45 plus theta. Now call this as an equation number 2. Call this as 1. So we know the formula. The angle of intersection between two curves is the angle of intersection between two curves is, it's an absolute value of phi 1 minus phi 2. Use this formula. Because why we are going to use this one? Here phi 1 and phi 2 we are extracting very easily. So that's why I have to use the value formula, that is phi 1 minus phi 2. You have to write on this, the value of phi 1 is theta, then minus of the second term 45 plus theta. Make a simplification. If a negative term I have to multiply it inside that, that is minus 45 minus theta. Now cancellation of these two, you get minus 45. It's an absolute value I have taken. This become a plus 45. So in terms of radian, we can write down as an pi by 4. That means the angle of intersection between two curves, that is a pair of polar curves, this is the required answer will be obtained for this problem. Okay. So I will explain again. So in this problem, they ask you find out the angle of intersection between pair of two curves. The first thing is you have to extract the value of phi 1 and phi 2, because two curves is there, you have to assume phi 1 and phi 2. So as usual, first we have to take the curve, then taking log on both sides, then after that taking a log on using the properties of logarithm, you have to split the function in this form. Okay. Then after simplified form in the form of a logarithm, then you have to differentiate this one. If you differentiate with respect to theta, you get like that. The one log r is 1 by r dr by d theta. So log 2 is a constant function. If you go into differentiation of constant function, they become 0. The log sin theta, the differentiation of log sin theta is 1 by sin theta. Logarithm function differentiation is 1 by of this function. Then differentiation of this function sin theta, they become cos theta. Then again theta with respect to theta we get 1. After make a simplification work, we get cos theta by sin theta, then cot theta. By the properties of trigonometrics, we are going to cancel these two cot, we get the value of phi 1 is theta. For the second function, that is in r equal to sin theta plus cos theta. For this function, again you taking log on both sides. Then after that, how to simplify it? It is a sum of two terms is there. It's not necessary for doing any simplification work by using the logarithm property. You keeping the entire term as it is. Then differentiation with respect to theta. The log r become 1 by r dr by d theta. Then should be equal to. Then again the logarithm function is there. It is in 1 by of this function, that is sin theta plus cos theta. The differentiation of inside the function sin theta will become a cos theta. Then cos theta is minus times of sin theta. Okay. Now take a common factor of sin theta here. If we take a common factor of sin theta, this is cos by sin, they become cot theta, then become 1. Then here also taking a sin theta as a common factor, it has become a 1. Then cos theta by sin theta, it's a cot theta. Now the sin theta cancel. It's in the form cot theta minus 1 divided by or cot theta plus 1. This is the formula we are used. It's cos 45 theta plus 45 plus theta. This is the formula we are used. Now cancellation of these two, we get finally 45 plus theta. So from these two equations we are extracting an angle of phi. I wanted here angle of intersection between two curves. You have to use this formula. So the absolute value of phi 1 minus phi 2. That is theta minus of the second term is 45 plus theta is there now in the second equation. You are going to substitute here now. Okay. Now cancellation of these two, we are getting a minus 45. It's an absolute value. The angle cannot be made as negative. I have to take it as positive. We convert it in terms of radian, we get pi by 4. Okay. So next we move to the another problem. In different approaches there now. The second problem is r equal to a times of log theta and r equal to a divided by log theta. So again I am going to extract the value of phi 1 and phi 2. This is the solution. R equal to a times of log theta. Now taking log on both sides now again. Taking log on both sides. This become log R will be equal to logarithm of a into log theta. I have to be careful about here now. Already one log is there. We are taking one more log. That is the logarithm of a into log theta. Now use the properties of logarithm. Log m into n. You have to remember log m into n. You have to use this formula. It is an log m into n. It should be equal to log m plus log m. Use this result to here now. Okay. So now we have log a plus then log of log theta. You have to remember here now. It is m plus log n. Okay, use this property. Log m into n. Now differentiate with respect to theta. I am going to do a differentiation with respect to theta. Okay. This becomes 1 by r dr by d theta. Know that differentiation of log r is 1 by r dr by d theta. Should be equal to, it's a constant function. Differentiation of any constant function, they become 0 plus. Now differentiation of this one. First you have to do the differentiation for logarithm function for this one. This become 1 by log theta. Okay. Differentiation of log is 1 by log theta. This is a function now. Now I have to differentiate inside the function. Log theta. The differentiation of log theta is 1 by theta. So carefully have to remember here. Now differentiation of this log theta is, it is 1 by theta. Then into, so inside the function. Okay. The theta is, make a simplification of work. Cot phi 1, you can call this cot phi 1, should be equal to 0 addition of this one, that's 1 by product of this theta into log theta. Okay, it is theta into log theta. You have to observe one thing. So here it's not possible for extracting the value of phi. You have to be careful about this. Suppose if any function is there, tan theta or cot theta, whatever is there, we can simply change in terms of cot and extract the value of phi 1. But here it is not possible. In that case, you can change in terms of tan. If you take the reciprocal of this, if taking reciprocal, what do we get now? The function entirely changes in terms of tan. That becomes tan phi 1. It should be equal to theta into log theta. So now I got this one, theta into log theta. You have to be careful about here. Okay. So why I am changing this tan? Because you already know the one of the formula. So here we cannot extract the value of phi very easily, but you have to change in terms of tan. You have to keep this in mind. The same procedure you have to adapt here also for extracting value of phi. So now here r equal to a times of log theta. Okay. The same procedure you have to adapt to extract the value of phi. Taking log on both sides, it's a logarithm of a by log theta. Now use the properties of logarithm. It is exactly in the form of log m by n. It is log m minus log n. I have to use this result for this one. M is a, it is a difference form is there now. Division form, it is a log m by log n. It is log m by n, it has become log m minus log n. Use that property. Log a minus logarithm of okay. Then differentiate with respect to theta. This is 1 by r, dr by d theta should be equal to, this is 0, then minus of 1 by log theta into 1 by theta into 1. Okay. So as usual, it is cot. Second curve I call as cot phi 2. It is a minus of 1 by theta into log theta. Okay. Now take the reciprocal, because here also it not possible to extract the value of phi. So that's why we are going to convert in terms of tan. Okay. Now take a reciprocal. Taking reciprocal. If you take a reciprocal, this become tan phi 2. This become tan phi 2 should be equal to minus theta into log theta. So now I am going to find out the angle of intersection between two curves. But here, this is called this as one equation, call this as a second equation. Have to use the equation 1 and 2, but the answer are obtained in terms of tan. So I am going to extraction the angle of intersection between two curves, that is phi 1 minus phi 2. You have to use the formula in terms of tan. So what is that? Here, the angle of intersection between two curves. The angle of intersection between two curves. What is that formula? That is tan phi 1 minus phi 2. Use this formula. We get tan phi 1 minus tan phi 2, then all divided by 1 plus tan phi 1 into tan phi 2. This is the formula we are used. That means we are going to substitute the tan phi 1 and tan phi 2 in that equation. Okay. So before substitution of the value of tan phi 1 and phi 2 in that equation, you have to find out the value of theta. We doesn't know the value of theta. So using the given equation, r equal to a log theta and r equal to a by log theta, you have to use this equation and extract the value of phi 1 and tan phi 2 value. Okay. So here, to find the value, of theta. Now to find the value of theta by using the given two equations. Using given equation. What is that given equation they given? So here r equal to a times of log theta and r equal to a by log theta. You can use these two because LHS are same. Both are containing LHSR. Then equating that, we get the value of theta. That is a log theta is equal to a by log theta. These two are cancelled. Make a cross multiplication. That is log theta whole square should be equal to 1. Then log theta should be equal to square root of 1 plus or minus. We are choosing only a positive value. Then finally we are getting the value of theta is, the base is the e power 1. Now I get the value of theta is pi. Because in absolute value I think that's why we are considering the plus value. Now finally we get the value of theta equal to e. Now substitute this theta equal to e in equation 1 and 2. Okay, what happens if I am going to substitute in equation 1 and 2? See here, if tan phi 1, you put theta equal to e, that's e into log e. What is the value of log e? Value is 1. You have to remember. Now that I want to substitute here now. After substituting the value of e in equation 1 and 2, if you substitute in equation 1, what we get now here? E, then log e. Log e value is 1, then totally tan phi 1 value is e. Then minus of the same thing here, I have to substitute here, e, then log e value 1, then minus of minus e, this become like this, then whole divided by 1 plus e into minus e. Then e plus e divided by 1 minus e square. Then totally 2e by 1 minus e square. That is tan of phi 1 minus phi 2. Phi 1 minus phi 2 is, it's a tan inverse of 2e divided by 1 minus e square. So this is the required solution for this particular problem. Okay. Understand this method? I explain again. So as usual, you have to take these two curves and extract the value of phi 1 and phi 2. So but in these two curves, we cannot extract directly the value of phi 1 and phi 2. If you want extraction of that two values of phi 1 and phi 2, you have to equating the given equation in this form. If I am going to equating this, we get the value of theta. The value of theta is e. Now after getting the value of theta e, you are going to substitute in equation 1 and 2. Now I am going to substitute these two. The substitution in these two equations, we get e into log e. The value of log e is 1, you have to remember. Then I am going to substitute here, tan phi 1 is plus e, then already 1 minus is there, tan phi 2 is minus e, then plus 2e, then 1 minus e square, then finally we are getting a tan inverse of 2e by 1 minus e square. So this is a solution for this particular problem. Again you are taking r equal to a theta divided by 1 plus theta, taking log on both sides. Log r equal to, it is a logarithm of a theta divided by 1 plus theta. Now use the properties of log m by n. This is log m divided by log n. Log r equal to log of a theta, then minus of logarithm of 1 plus theta. Okay. Now again one more property is there, logarithm, product of two function is there. Again you apply the logarithm property, this become log r equal to log a plus log theta minus logarithm of 1 plus theta. Okay. Now we have to differentiate this one. Differentiate with respect to theta. It's clear? It is 1 by r, dr by d theta should be equal to, the differentiation of log a becomes 0. This become 1 by theta into 1 by theta minus the differentiation of this 1 by 1 plus theta. Make a simplification work. This become cot phi 1, taking LCM here, then theta into 1 plus theta is the LCM. We have 1 plus theta minus theta. Now cancellation of these two will get 1 by theta 1 plus theta. If we take the reciprocal of this, we get tan phi 1 is theta into 1 plus theta, or simply theta plus theta square. Now what the value of theta is like this, tan phi 1. You have to remember why I am going to use tan phi 1, because it is not possible for extracting the value of phi directly. So that's why we are going to convert cot in terms of tan. The same procedure for the second equation. R equal to A divided by 1 plus theta square. Okay. It is a log R should be equal to logarithm of A divided by 1 plus theta square. Log R equal to log A minus of logarithm of 1 plus theta square. Now differentiation of this one. It is 1 by r, dr by d theta. This is 0. It is a minus of 1 by 1 plus theta square into 2 theta. The value is cot phi 2 should be equal to minus 2 theta divided by 1 plus theta square. If I take the reciprocal, then tan phi 2 should be equal to minus of 1 plus theta square, then whole divided by 2 theta. So now I am going to find out the value of theta. Now equating these two equations, now find out the value of theta. Now to find the value of theta using equation 1 and equation, the given equation, sorry, not equation 1, using the given equation, What the given equation? That is r equal to a theta by 1 plus theta, then r equal to a divided by 1 plus theta square. Using these two and extract the value of theta. That is an a theta divided by 1 plus theta and should be equal to a divided by 1 plus theta square. Make a cross multiplication. These two are cancelled here. Theta into 1 plus theta square. Here 1 is there, 1 into 1 plus theta. Then theta plus theta power 3 should be equal to 1 plus theta. Now cancellation of these two. Now I got the value of theta is 1. What the obtaining value of theta here? You have to substitute in equation 1 and 2 to get the value of tan phi 1 and phi 2. Substitute theta in equation 1 and 2. Now I am going to substitute theta equal to 1 in equation. Substitute theta equal to 1 in equation 1 and 2. What happens if theta equation 1 becomes, now check it here. Now what happens if equation 1 becomes? Now if equation 1 becomes, in place of theta I put 1 here. So this is theta is 1 plus 1 square, they become 2. Or tan phi 1 value is 2. And equation 2 becomes, now just substitute theta equal to 1 here. What happens here now? 1 plus 1, they become 2. 2 into 1, they become 2. That is 2 by 2, the value is minus 1. Then tan phi 2 minus of 1 plus 1 divided by 2 into 1. Then tan phi 2 is, this is 2 by 2 along with negative, have minus 1. It's clear. Of the obtaining value of theta equal to 1, we should have to substitute in equation 1 and 2, then extract the value of tan phi 1 and phi 2. Okay. Now putting theta equal to 1 here, 1 into 1 plus 1, they become 2. Here we get the value of tan phi 1. Then as usual, in equation 2, 1, then plus 1, 1 plus 1, 2. This I am writing here now. Its minus is there now, keeping the minus value as it is. Then 2 by 2, they become 1. So now getting the value of tan phi 1 and phi 2 now. Now we have to find out the angle of intersection between two curves. We know the formula. Angle of intersection between two curves. We know the formula. What is that formula? It's an absolute value of tan phi 1 minus phi 2. It should be an absolute value of tan phi 1 minus tan phi 2, then all divided by 1 plus phi 1 into tan phi 2. What is the value of tan phi 1 now? It is 2. Minus of minus 1 divided by 1 plus 2 into minus 1. This is 2 plus 1 divided by 2 minus 2. Become 3 by minus 1. It is an absolute value. So this is minus 3. In generally, the value of absolute value of minus 3 is plus 3 minus 5 and 2. It is a tan inverse of 3. It's clear. So I am explaining again clearly. So what they given? The curve you have to take to extract the value of phi 1 and phi 2. But in this equation, we doesn't extract the value of phi 1 and phi 2 directly. For that, we have to convert in terms of tan theta. Okay. Here in equation 1 and 2, the tan theta will be obtained, tan phi 1 and phi 2, tan phi 1 and phi 2 obtained in the form of theta. If you go to elimination of these theta, equating the given equation, what they given here, you have to equate this given equation to extract the value of theta. After obtaining the value of theta, you want to substitute in equation 1 and 2. That is tan phi 1 and tan phi 2. So we get like this, tan phi 1 value we get 2 and the tan phi 2 value is minus 1. Okay. So then after that, use this formula. The angle of intersection between two curves. That is tan phi 1 minus phi 2. This is the formula, tan phi 1 minus phi 2 divided by 1 plus tan phi 1 into tan phi 2. Okay. So now substitute the respective value of tan phi 1 value. What they are obtaining here, tan phi 1 value is 2. Now I am going to substitute here 2. Minus is from formula. Tan phi 2 value, we are getting a minus 1. Now I am going to substitute here now. It is minus of minus, they become plus. 2 plus 1, 3. Then all divided by 1 into minus 2. The product of these two is minus 2. Then 1 minus 2 is minus 1. This plus divided by minus is minus. We are getting a minus 3. We are considering only an absolute value. Your negative also become a positive. So then finally we are getting a 3. If you transfer the tan terms to the right hand side, they become an inverse function. It is phi 1 and phi 2 is tan inverse of 3. Okay, so this completes the part of the problem, how to find the angle of intersection between pair of two curves. Okay. Now thanks for watching this video.